I bet you've heard of stable diffusion models for AI image and video generation. If you don't have a background in programming or machine intelligence, it can be hard to conceptualize what a generative algorithm is actually doing between receiving your prompt and creating your desired output. To begin with, here's a brief summary. Diffusion models work by gradually refining an initial random noise signal until it converges into a specific image. They're like a reverse process of how humans perceive things. The human brain performs the task of processing sensory input by disregarding features that aren't relevant to an object's core identity, such as how much light is shining on it or what angle it's being viewed from. What's left is known as invariance, meaning objects are perceived as the same, even if they show differences in less important features, because they share underlying invariance. There are many examples of objects that remain recognizable despite changes, like an individual face, recognizable despite varying light and shadows, or a landmark seen from different angles. A tree silhouette against a bright sky comes to mind too. It remains recognizable despite changes in background brightness. Even if the wind moves the silhouette, a human brain still recognizes it as the same tree. That's a good illustration of variance and invariance, and how they both affect perception. Diffusion is the mirror image of this perceptual process, with the model iteratively correcting its guess about the object described in the prompt until it gets it right. This is the inverse of human perception because it's about generation of new content, not classification of existing content. Stated another way, a stable diffusion model has to get to the invariance of objects in the opposite of the way humans perceive, more like dreaming, as opposed to seeing or hearing something external and processing what it is. In the context of diffusion models, stable refers to the ability of the model to produce consistent results without diverging or exploding during the iterative refinement process. Yes, I said exploding, but no, I don't mean a fiery Hollywood explosion. I mean a combinatorial explosion where combinations and recombinations of possibilities consume astronomical amounts of computing power, kind of like folding a piece of paper again and again, quickly going from a single layer to hundreds of thousands. This combinatorial explosion and the impossibly huge amount of computing power it would consume was a limitation on AI in past decades. It took a lot of work and innovations in machine architecture from very smart programmers and scientists to move beyond it. Anyway, the stability in diffusion ensures that the model produces meaningful and coherent outputs rather than getting stuck in an infinite loop or producing absurd results. Though the absurd glitches and surreal artifacts of early generative AI were indeed hilarious, and I'm a bit nostalgic for them. It might make it easier to conceive of what stable diffusion is if you imagine what unstable diffusion would be. Unstable diffusion could be a loose, uncontrolled process where the model jumps randomly between different possibilities without converging towards a specific outcome, like wild associations flowing freely in a stream of consciousness. Diffusion is about exploration, while stable means the exploration leads to a clear and coherent result. It's a balance between creativity and focus. Stable diffusion could be compared to a chef perfecting a recipe. At first, it's just a chaotic mix of ingredients, but with each iteration, they refine it until they serve the perfect dish. At the outset, the chef knows in theory what the prompt means. For instance, make a muffin, but needs to combine ingredients in an iterative process to arrive at that result. Yes, that's an image generated through stable diffusion to illustrate stable diffusion. Surreal humor is our vibe. Anyway, The chef knows the desired outcome, but needs to adjust the ingredients and cooking process through trial and error to achieve it. It's like the model is refining its guess based on feedback from each step, both during the actual generative process and also over the course of the training. Training a generative AI model is an essential step. Any AI model you interact with has been extensively trained prior to its release for public use. It's a detailed, complicated, expensive, data-intensive thing, but that's a whole different can of worms, as they say. Though AI art generators are where most people have probably encountered the term, these models aren't only about image and video generation. The concept of stable diffusion has applications in various other domains, in everything from audio synthesis, being used to create realistic sound effects or music, to material sciences and pharmacology, where it could help design new molecules with desired properties. Picture things like new drugs in medicine or extremely heat-resistant ceramics in rocket engines. Stable diffusion models also have applications in natural language processing, generating coherent and contextually relevant text. I mean, obviously, but I'm not trying to brag. These are just a few examples. The versatility of stable diffusion models opens up exciting possibilities for future research and development across different fields. Scientists could use stable diffusion to generate detailed 3D models of extinct or newly discovered species, or even entire ecosystems, allowing for more accurate analysis and study. It could also help identify patterns and relationships within complex systems that wouldn't be visible otherwise. Artificial intelligence recently aided in the invention of a novel type of battery which doesn't require rare earth metals, potentially, someday, reducing demand for mining operations worldwide. In the words of Leonardo da Vinci, "Learn how to see. Everything connects to everything else." That quote really captures the essence of creativity and exploration, just like stable diffusion. Everything truly is interconnected. So the next time you're using a stable diffusion model to generate images or videos, remember that there's a lot going on under the hood with this powerful technology. If you enjoyed this video and want more stuff like this, be sure to check out our other videos about generative AI. Until next time, stay curious and keep exploring.